Welcome to Unit 4, Lesson 18, the quadratic formula and complex solutions. Let's use the quadratic formula to find complex solutions to quadratic equations. Okay, so here is the quadratic formula. When you have a quadratic equation, ax squared plus bx plus c, you first have to identify a. A is the number in front of the x squared term. B is the number in front of the x term. You might not always have a B. And C is the number in front of, is the constant that has no x after it. So you might not always have a C. You have to have at least an A for it to be quadratic. Then here's your formula. The B term, the negative of the B term, and be careful with this. We're going to see that you must use parentheses to keep your sign straight, and then plus or minus the square root of b squared minus 4ac all over 2a. Now we have to remember, when numbers are next to letters, it means multiply. The order of operation is multiply. So let's remember that, as long as a is not equal to 0. If a is equal to 0, it's not a quadratic equation. Okay, so let's solve partner A. We're going to solve the one in the top row first. So I'm going to use the quadratic formula since it is already in equal to 0. So my A is 1, my B is -4, my C is also -4. So negative of -4 plus or minus the square root of B, which is -4 squared minus 4. The -4 is part of the equation, so it's nothing to do, times -4, all over 2 times a. So this is all part of the equation. Negative of -4 is 4, plus or minus the square root of 16. -4 times -4 is positive 16, all over 2. I get 4 plus or minus the square root of 32 over 2. 32 simplifies to 16 times 2. 4 and 8 worked, but 8 is also divisible by 4. So when you simplify a radical, you want to look for the largest perfect square that goes into the radical. So I get 4 plus 4 root 2 over 2. So I get 4 over 2 plus or minus 4 root 2 over 2. I cancel out my 2's. I get 2 plus 2 root 2 and 2 minus 2 root 2. All right, on the right side, I am going to do, I can just square root both sides. If I square root both sides, I get x minus 2 is equal to 8 is equal to 4 times 2, so that's 2 root 2 plus or minus. I add 2 to both sides. I get x is equal to 2 plus 2 root 2, and x is equal to 2 minus 2 root 2. Okay, so for the second row, I'm going to square root both things. -8. Separate this at -1 times 4 times 2. So y minus 2 is equal to, the square root of 4 is 2. The square root of the square root of -1 is I, root 2. Oh, this is the same as the one above. Oh, these are the same things. Okay, add 2 to both sides. I get y is equal to 2 plus 2i root 2 and 2 minus 2i root 2. Now for the B, for the second row, I'm going to use the quadratic equation, which is going to give me my A is 1, my B is -4, my C is 12. So that gives me negative of B, which is -4. This is why I always use parentheses. Plus or minus the square root of b squared, -4 squared, minus 4 times a times c, all over 2 times 1. So I get 4 plus and minus the square root of 16 minus 48. 4 times 12 is 48 over 2. I get 4 plus or minus the square root of negative 32 over 2. Well, from the previous page, we learned that negative 32 was what? 16 times 2 is 4. So this is 4 plus or minus 4i root 2 over 2, which is, when I separate the 2's out, I get 2 plus 2i root 2, and then 2 minus 2i root 2. Look at that. They look different, but they wound up being the same thing. You know, I bet if I multiply the parentheses out, I would get the same equations. Okay, so let's do root 3. So we're going to take the square root. 29 is a prime number, so I'm going to get z plus 3 over 2 is equal to negative, what am I doing? I, because it's negative 1 times 29 over 4. I root 29 over 2. The square root of 4 is 22. So from our rules, if I do negative 1 times 29 over 4, it's the same as the root of 29 over the root of 4. I can separate my roots. So z is equal, so I got a minus 3 halves from both sides. I get z is equal to negative 3 over 2 plus I root 29 over 2 and negative 3 minus I root 29, and they're both over 2. And I'm going to go ahead and combine the equations. So negative 3 plus I root 29, the whole thing over 2. Since they had the same denominator, I can add them. But since they're not like terms, I can't combine them. Okay, these are my two answers. All right, let's see what happens when we use the quadratic formula on the right side. So 2z. So negative of 6 plus or minus the square root of 6 squared minus 4 times 2 times c, which is positive 19. Why? This is not equal to 0, so I have to add 19 to both sides to make this equal to 0. So once I move to 19, this becomes 0. All over 2 times 2. All right, so I get 6 plus or minus the square root of 36, which is 6 squared, minus 4 times 2 is 8 times 19 is 152. All over 4. We get 6 plus or minus 116 over 4. Now I have to divide this by perfect numbers to see if this is factorable by anything. The only numbers that multiply to make 116, well, not the only numbers, but the largest perfect square is 4 and 29. So when you simplify a radical, you must divide it by a perfect square. And 4 is a perfect square, so that means it's 4 times 29, that's 116, times negative 1, all over 4. And you get 6 plus or minus, the square root of 4 is 2. The square root of negative 1 is I, root 29, all over 4. Now, if I simplified it down, if I took a 2 out, I would get the same thing as the left side. So these are equivalent. Okay, if we look at the next one, we see that the 5 is not on the left side. This equation is not equal to 0. So the first thing we're going to do is move the 5 over to make this equivalent to 0. Our A is 1, our B is 3, and our C is -5. Okay, so now when you have a trinomial, a quadratic trinomial, now we're going to use the quadratic formula. So the negative of B, no, B is 3, I'm sorry. I'm looking at C, not B. The negative of B, whatever B is, put it in parentheses. You won't mess up the signs. You will not mix up the signs. B squared minus 4 times A times C over 2 times A. Now, I could run through the proof, but you could Google it online, look at the proof, and see where this formula comes through from. 3 squared is 9. -4 times 5 is +20 all over 2. We get 3. -3 plus or minus the square root of 29. 29 is a prime number. It only has 1 in itself as a product, all over 2. 3 plus or minus the square root of 29 all over 2. All right, that's the most we can do with that one. Okay, so for the one on the right, take the square root. So you can separate the square root top and bottom. So you get W plus 3 over 2 is equal to the square root of 29. The square root of 4 is 2. So we're going to leave it like that. You subtract 3 halves, well, plus or minus. Don't forget your plus and minus. I'm sorry about that. Minus 3 halves on both sides. And W is equal to -3 halves plus or minus the square root of 29 over 2, which is the same thing as the left side, because we know when you have the same denominator, you can separate your fractions. If you had the same denominator, you can combine the numerators. Okay, last row. Now, this trinomial is already equal to 0, so we can just put this right into the quadratic formula. So -b plus or minus the square root of B squared. Make sure you use parentheses, minus 4 times A times C all over 2 times A. Okay, we get 20 plus or minus 20 squared is 400. 8 quarters, wait, no, 16 quarters are 400. Over 8 is 20 over 8, because 400 minus 400 is 0. And so on the right side, if we divide by 4, we get t squared minus 5t is equal to -25 over 4. Now, why am I doing it like this? I have to complete the square, so I do -5 divided by 2. I square it. I get 25 over 4. So I had to add 25 over 4 equals -25 over 4 plus 25 over 4. Now, this becomes inside my parentheses with my t squared. So I get t minus 5 over 2 quantity squared equal to 0. And then square root t equals 5 over 2. And 20 divided by 8, if you divide it by 2, well, 2 is not big enough. Let's divide it by 4. You get 5 over 2. So you get the same number from side to side.